Hello, good afternoon my dear students. Welcome to one more amazing session from Sri Chaitanya Academy Infinity Learn NEET YouTube channel. How are you all doing? That's fine. So in this Nrimaan 1.0 series, we are going to discuss alkenes in today's class. In the previous class, we had a discussion with alkenes. In the hydrocarbons, I want to make into three segments. One is alkenes, another one is alkenes, and upcoming session we are going to get into alkynes and aromatic hydrocarbon. So that organic part in the grade 11 NCERT textbook at NEET level we are going to discuss in this week. That is the agenda, my dear students, in 2026. The organic chemistry that has been presented, it is little difficulty level. It is not like as simple as that happened in 2023 and 2024 and 2025. So I strongly believe in this 2027 upcoming NEET examination, even you are going to face a difficult level question, mean to say multi-concepted questions in the NEET examination. So why late, without any delay, we are going to start with alkenes. Alkenes are unsaturated hydrocarbons. They are also said to be olefins. Because of the carbon to carbon double bond, their reactivity is going to be taken into the top priority, because once you are done with alkene, it is connected to alcohol, it is connected to alkyl halides. So organic chemistry you have to study in such a way that it is a cumulative effect. So those students who are online, please like the session, share with your friends, subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel. In this YouTube channel, we are providing the sessions. We are not expecting anything from any student. Just we request you to simply like the session, share with your friends. Your subscription does matter for us. And these YouTube sessions, do you feel, can you clear NEET examination with YouTube sessions? Definitely you can, and you can be a topper as well. So since last 3 years, we have taken the analytics also from our database. Majority of the students who are relying on our YouTube channel is getting NEET the best results, even it is 2027. So anyways, let's start without any delay. Preparation of alkenes, controlled hydrogenation of alkynes. So any unsaturated compound, so you want to say alkyne, when you add a hydrogen it becomes an alkene and it becomes an alkane. In this scenario, you have exhaustive hydrogenation. This was an alkyne. You can use a hydrogen and the palladium you can use. Also, you can use a platinum, or you can also use a nickel, whose oxidation state is 0, I wanted to say. So direct hydrogenation takes place, that is uncontrolled hydrogenation, or you can say exhaustive hydrogenation. You can't stop the reaction. But if you could able to use any catalytic poison or any uncontrolled controlled hydrogenation, you are going to get alkene. Yes, you see here partial reduction by using a Lindlar's catalyst. I teach only online with Sri Chaitanya Academy Infinity Learn, right? So have you seen me offline classes also? Where did you see? Okay. Shlok. Okay. So you can see here, when alkyne is treated in the presence of the same catalyst H2 and PD, but I want to use calcium carbonate. You can also use barium carbonate, or you can also use a barium sulfate in the presence of quinoline as a solvent. You are going to see syn addition, so that hydrogen is going to be added at the only one side of this triple bond. So I am a Shlok from JEA B3 batch. Very good, nice. Right, now talking about, it is going to be a cis product and it is a syn addition. Addition from one side is called as syn addition. The secret batch. Okay, come on, let us focus on the concept that is going on here. So if you have, those who are online, if you have any doubts, please ask, so that I can discuss your doubt Any academic doubts that you are presenting in the class will be honored. So let us maintain chart diagram. Let us talk about the Lindlar's catalyst is over, and you can see the Birch reduction. When alkyne is treated with sodium, or you can also use lithium, and in the presence of liquid ammonia, you are going to get anti-addition, so the product you are going to get a trans product. So this is exhaustive hydrogenation, and this is a controlled hydrogenation. In this controlled hydrogenation, you have two parameters. One is reduction by using Lindlar's catalyst, and reduction by using sodium and liquid ammonia, or lithium and liquid ammonia. Any doubts, my dear children? Come on. So let's see in the detailed version of this exhaustive hydrogenation. In the exhaustive hydrogenation, you can see alkyne is converted into alkane. So what exactly happened? The hydrogen gas is going to adsorb on the surface of the palladium catalyst. So that the palladium catalyst is going to, hydrogenated palladium catalyst is going to attack from the same side of this linear structure of the alkyne. So as a result of this, you are going to get hydrogen is placed on the one side of the alkyne, so that you are going to get alkene, and this is syn addition. And you can see one more hydrogen can be added. In the same way, you are going to get a final product, so that it is a complete or exhaustive hydrogenation. Complete or exhaustive hydrogenation. So alkyne first gives alkene, and this alkene further react, and finally it is going to give rise alkane, right? Any doubts, dear children? One thumbs up and fire emoji in the live class, so that Shlok, any doubt? Now let us talk about the controlled hydrogenation. In this controlled hydrogenation, you can see partial reduction. As I said, it is a partial reduction. Two hydrogens are added one side, so it is a syn addition. As a result of the syn addition, you are going to get a cis product. How it is going to get a cis product? The same way, hydrogen is going to adsorb on the surface of the palladium, so that the palladium, hydrogenated palladium, is going to attack on the alkyne triple bond, so that you are going to get the syn addition product, and the reaction stops here. इस यहाँ से reaction आगे बढ़ने मुश्किल है बेटा. So that the product is going to be like this. Now I just want to add one more question here. If this is the alkyne, right, when it is treated with D2, PD and BaSO4, and in the presence of a quinoline, and it could be isoquinoline, you are going to get a product like this. So it is going to be D2, syn addition product, D and D. Are you getting or not clear? Fine. And this is going to be very important. Let us talk about the Birch reduction here. So this is how the structure of this, an example you can see. This is a double bond present in the benzene. It is a triple bond outside the benzene. Double bond present in the benzene is not reacting. So that outside the triple bond is going to be reacted. So you are going to get a cis configuration, or E and Z isomer, Z product is going to be observed. Let's talk about here again Birch reduction. You can see here, this is the same. So in the Birch reduction, sodium is a metal with the lowest ionization energy. So this sodium loses electron. The electron lost by the sodium is going to be trapped by the carbon to carbon triple bond, so that you are going to get a radical this side, anion that side. Radical this side and anion this side. So you can write this. And this is sp2 hybridized anion is going to be taken the hydrogen, so that from ammonia, the hydrogen present in the ammonia has an acidic nature. So you are going to get a hydrogen attached in the one side. The same is repeated again to get one more anion radical. So it is going to finally gives 2 hydrogens on the opposite side. So, final product is going to be a trans product. You can see here it is an anti-addition, and the product you can see it is as a trans product. Any doubt children, any doubt? If you have any doubt, please let me know. So, in the preparation of alkane we are studying alkane as well. So, in the NEET examination the stereo specificity is very, very important, right? Now, moving ahead, one more important thing, if this is an alkyne, if it is treated with the sodium in liquid ammonia, you are going to get an anti-addition product. So, you are going to get a trans product. Here this NH2 minus is a super basic co-product. So, that anyways sodium is there, it is going to be taken away by the NaNH2. It is a source of protons is required, so that aqueous NaHSO3 can be used for this. Assertion reasoning questions, what is the role of this NaHSO3? So, the byproduct that is formed NH2 minus is going to be abstracted here. So, this is a very important reasoning question for your NEET examination. बच्चों अगर कुछ डाउट है ना तो आप ये लाइव शॉट में आप बता सकते हो, ठीक है? So, moving ahead my dear children, here this is alkane NaNH3 liquid ammonia, you are going to get a trans product, right? And similarly, if this is a triple bond, if this is a triple bond, you are going to react this with NaH2 in Lindlar's catalyst, I mean to say PD and BaSO4 in the presence of quinoline as a solvent. You are going to get all are going to be cis E isomer and E isomer, and you are going to get G isomer, anti-Gigen Jusamen. How many of you memorize this? How many of you memorize this E and Z isomerism? It means here it is, you can say a trans, here you can say cis, here you can say cis. Now, moving ahead here, if it is a double bond and a triple bond, you see the comparison between the two reactions. H2 and PD, it is an exhaustive hydrogenation, so that double bond is going to be hydrogenated and a triple bond is also completely hydrogenated. So, finally, you are going to get an alkene. While you can see Sloke, double bond is there and a triple bond is there. When hydrogen and Lindlar's catalyst is used, you are going to see only triple bond is going to be hydrogenated, so that you are going to see it is a Lindlar's catalyst, hydrogen and a hydrogen. But this double bond is not reacted in the presence of Lindlar's catalyst. You see the difference between this product and this product, and it is a self-explanatory examples that can give you the super awesome idea about how the hydrogenation can be done in exhaustive way or in controlled way. Any doubt, dear children, any doubt? Now, moving ahead, dehydration of alcohols. When alcohol is treated with acid, removal of water takes place, so that alkene is formed. This process is called as dehydration. Let us see here. It is a E1 reaction or it could be E2 reaction. So, elimination by unimolecular reaction. Elimination unimolecular reaction. So, E1 mechanism in that carbocation is formed. You can see when Alcohol is treated along with concentrated H2SO4. Water molecule can be eliminated, so that OH is eliminated here and hydrogen from here it is eliminated. So, this is the product. Hydrogen from here it is eliminated. So, hydrogen from here it is eliminated, you are going to get this product. You have two types of products, very important. One is ZF product, or this is also called as ZF product. Another one is a ZF product, and this is what is called a Hoffman product, less substituted product and more substituted product. According to ZF rule, more substituted product is the major product in this. So, in ZF rule, even reactions gives the more substituted alkene. Let us see the mechanism, because this product is decided based on the stability of the carbocation. More is the stability of the intermediate, major is the product. And let us see here the same. Remember, always you see this is a double bond, so one substituent is there. This is a double bond, one substituent and another substituent is there. You can say this is your methyl group, and this is your methyl group, and this is your methyl group, and these are all the different methyl groups over here, and like this, and like this, and like this, and like this. So, more substituted alkene means this is. So, the stability of alkene is explained on the basis of a hyperconjugation. More the number of alpha hydrogen, more will be the number of hyperconjugation structures, and measure is the more is the stability. So, the tip I just want to give you, higher, so what is that, higher the circle group, you can say major product or more stable alkene. Let us see the mechanism here, the same what we have seen in this scenario. I want to show you the mechanism here. Look at this. When the lone pair of electron present on the oxygen of the alcoholic group is a Lewis base, it is going to abstract H plus from H2SO4, so that OH is a poor leaving group, and if it is once it is a protonated, OH2 plus banega, a OH2 group, OH2 plus is a good leaving group. So that the lone pair of electron is given on the oxygen, so that water molecule is eliminated, ताकि आपका कार्बोकैटायन यहाँ पर बन जाएगा. This is a carbocation. This carbocation, the primary hydrogen can be eliminated, so that you are going to get the product here. This carbocation, its beta hydrogen from here it is eliminated, so that this product is going to be formed. So, these are tertiary carbocations, where I want to say this is more substituted, therefore you can say it is a major product. Any doubts, students? And moving ahead, one more question I just want to give you here. So, if carbocation is formed, it is going to participate in the rearrangement. What is this? I will tell you. This is an alcohol. When alcohol is protonated, you are going to get a very good leaving group, so that you are going to get a carbocation here. So, this is eliminated as water molecule, so that you got a secondary carbocation. So, positive charge on the secondary carbon is a secondary carbocation. This secondary carbocation, one of the methyl group that is present here. So, this methyl group is shifted here from here to here. So, we can say methyl shift 1 comma 2 methyl CH3 minus shift. So as a result of you got a tertiary carbocation, and this tertiary carbocation can lose a H plus so that a product can be formed, or you can also lose a hydrogen from here so that you are going to get another product. If you see this product, I can see these 2 substituents are there. Here I can see 4 substituents are there. So it is more substituted alkene is a major product. During elimination reaction, the more substituted alkene is the major product. More substituted alkene means it can have more hyperconjugation structures due to more number of alpha hydrogens. So follows most of the elimination reactions are ZZO products. Sometimes Hoffman product is also formed. I am going to tell you what is the condition there. You can see the Hoffman product. Fine. Any doubt? So children, moving ahead here, dehydrohallucination is the another reaction. So far we have seen dehydration reaction, you are going to get dehydrohallucination reaction. Here you can see either E1 or E2. If it is a tertiary alkyl halide, it follows E1. If it is a primary alkyl halide, it was a secondary alkyl halide, it can participate in the E2 reaction. Let's see what is a dehydrohallucination reaction. So alkyl halide, this is the leaving group and this is alpha carbon, and adjacent to this it could be a beta carbon atom or it could be a beta carbon atom. So I mean to say halogen from one carbon atom, and you can remove the hydrogen from the adjacent carbon atom so that you are going to get an alkene. So hydrogen and halogen together are eliminated. This process is called as a dehydrohallucination. For this you need definitely high temperature, because elimination reactions are endothermic reactions, and you need a base in this reaction. It could be E1 or E2. I am going to explain you the mechanism as well. It is a E2 reaction. You can see this is alpha carbon atom and this is a beta carbon atom and this is a beta carbon atom. If you use a base here, you use a base here. A base can be a traditional base or any alkoxide bases. So if it is eliminated between these two, you are going to get a new pi bond is being established, and it is the more substituted alkene and it is a major product. So concerted mechanism, all it happens in a single step. So I don't want to give you a base. This is a base. What is the meaning of a base? A base is the one which eliminate, which attack at the Hu plus. So beta hydrogen, this is alpha carbon, this is a beta carbon, hydrogen attached to the beta carbon is a beta hydrogen. So that base is going to abstract a beta hydrogen. So it is a concerted mechanism. This is a leaving group, so that you are going to get a new pi bond formed here. So this reaction is called as a E2 reaction. See, in this E2 reaction, the leaving group and the beta hydrogen should be anti in direction, opposite, anti in direction. That is the key point. Any doubt? Now let us see here. An example here, cyclobromo cyclopentane. So in that is a substrate. When you give, what is this? Potassium tertiary butoxide. You can see CH3 and you can see CH3, you can see CH3, O minus and K plus. So this is going to abstract the bromine and the hydrogen. So you are going to see the zoomed version of the structure, you can see. So this is a cyclopentane, alpha carbon and a beta carbon. Here is also beta carbon. So that the potassium tertiary butoxide is a base, and this base is going to abstract the beta hydrogen, so that it is a concerted mechanism, so that bromine is eliminated, hydrogen is eliminated, a double bond is formed here. As a result of this, the bond product is going to be like this. Any doubt? Children, any doubt? You all like this example? So at the end of this session, the entire class notes is given as in the PDF form in the Telegram channel. You please join in the Telegram channel so that you will understand. So it will be your notes as well. Fine? Right. So moving ahead here, one more question here. So E2 requires a strong base. What is the base? A base is the one, a species which attack at H place. What is the nucleophile? Nucleophile is a species which attack at the positive charged carbon. It do not, if an anion attack at C plus, it is a nucleophile. Anion, if it attack at H plus, is said to be a base. So normal bases, you all know it's a normal base, sodium hydroxide. Yes, it is sodium plus an OH minus, it's a base. And potassium hydroxide, OH minus is a base. Now you can say alkoxides, methoxide, ethoxide, isopropoxide, tertiary butoxide. You can see as moving down here, as the number of carbons in the base is increased, the bulkiness of the base increases. Lithium diisopropylamine, it is an amide, is a base, NaNH2, it is used like this. And LDA, that is lithium diisopropylamide, it is a bulky base, super bulky base. It is highly selective. Tertiary butoxide is also a bulky base. And other like DBN, DBO are there, and which we don't use at the level of NEET examination. You don't have to worry about that. And moving ahead here, you can see, I want to take bromoethyl cyclopentane. You have a blue color beta hydrogen, a pink color beta hydrogen. The same thing here, blue color beta hydrogen and a pink color beta hydrogen. And if whenever you use a smaller base, you are going to take the beta hydrogen interior of the molecule, so that more substituted product is formed. More substituted product is the major product according to Zaitsev rule. The other is going to be the minor. But the scenario is going to be opposite. When you use a bulky base, the bulky base cannot go interior of the molecule to pick this pink color hydrogen. Rather, this bulky base is going to take the exterior of this molecule to pick this, abstract this beta hydrogen, so that a double bond is formed outer side of the molecule. So that is less substituted alkene. And less substituted alkene is the major product that is given by Hoffman product. So when a bulky base is used, Hoffman product is the major product. If a smaller base is used, you are going to see the Zaitsev product. So, smaller the bases favor the J is the product, bulky bases favor the Hoffman product. So, this is a key noteworthy important points you need to know before you go into the cracking NEET examination. So, in this YouTube channel, we are giving you the genuine level of the subject, right? You don't have to worry. Starting, Shlok, have you got any doubts? So, this is the live chart. You can use any doubts, use this live chart, ask any kind of doubts. So, moving ahead, some more examples here. So, general scheme of alkene hydration. You have seen preparation of alkynes. Now, you are going to see hydration of alkene. You take alcohol, remove water molecule, alkene is formed. Reverse the process. Alkene, you add water molecule, you are going to get alcohol. You see, this is an alkene, and when water is added in the presence of acid as a catalyst, you can use this acid as a catalyst. So, you can use H2SO4, you can use H3PO4. So, that H2O contain H plus and OH minus. So, H plus and OH minus is formed, alcohol is formed. This is an acid catalyzed reaction. So, for this process, either you can use H2SO4, H3PO4, but you cannot use HCl, HBr, HI. So, in the NEET examination, assertion and reasoning questions can be asked. So, this is the reason why HCl, HBr, HI are not used, because they are Cl minus, Br minus and I minus are the nucleophiles. So, moving ahead here, let us see the mechanism here. Mechanism of the acid catalyzed hydration. Add H plus from H2SO4 directly, this is an alkene and this is alkene. So, the pi bond of the alkene act as a nucleophile, abstracts proton over here, so that carbon cation is going to be formed. Once this carbocation is formed, so formation of an electrophile first, like H2O takes the hydrogen from the H2SO4. Now, you are going to get proton hydronium ion. This hydronium ion is going to be the electrophile. This is your electrophile. And this electrophile is going to attack on this carbon to positive charge over there. So, you are going to see the formation of, yes, later on it is dehydrated. So, OH2 plus and it is protonated, and you are going to see this formation of this OH like this. Let us see the another one. So, this is a methyl cyclohexene. What happened if water in the presence of H2SO4 is added? I want to know how you do this question. How you do this question, Jaldi. So, quickly you do by using a pen and paper, and you can tell me the answer for this question. Let us see the systematic version of this formation of an electrophile. Like H2O takes H plus and become H3O plus, it is an electrophile, right? and this electrophile is going to attack on the pi bond here. So electrophile attack, when this electrophile is being attacked, carbon to carbon positive charge can be formed. If carbocation is formed at this position or carbocation is formed at this position, if one number position you are going to get a tertiary carbocation, if it is two number position you are going to get a secondary carbocation. Tertiary carbocation is more stable as compared to the secondary carbocation. So I just want to say this is the product generated radical. And you see here nucleophilic attack, the OH2 is going to, so H2O, the lone pair of electron attacks on the H carbocation, so that protonated alcohol is formed, and this is deprotonated, of course, so the final product is formed like this. It is a major product. Are you getting or not, dear children? Any doubt? Now, moving ahead, you have to follow. So, addition of water in the presence of alcohol is going to be a Markovnikov rule. The Markovnikov rule says the negative part of the reagent carbon bearing least number of hydrogen atoms. Somebody asks you the definition, you follow this definition. You can see X and H, H plus and OH minus, X minus and H plus. Negative part of the reagent goes to a more substituted carbon, carbon double bond, so it is a more substituted, so that OH should be there. So this is what is called as Markovnikov's rule. Any doubt, children? Follow this Markovnikov rule, and in the next class, we are almost done with the time. In the next class, we will meet with more stuff, okay, and we will meet with more number of questions as well. Now, as the time is exhausted, we shall meet with more stuff in the next class. So, those students who are online, please like the session, share with your friends, subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel, and you follow our lectures and subscribe to this channel. So आगे आने वाला के जो classes है आपको पता चलेगा, notifications भी मिलेगा. And please subscribe this channel and join into the Telegram group, so that the session notes you are going to get at the end of the session in the PDF form. Okay, time is up. We will meet with more stuff. Thank you very much. Thank you.